this video, we're taking a look at Schwann cells. Schwann cells are supporting cells that mainly surrounds peripheral nerves. And in the peripheral nervous system, Schwann cells are the only supporting cell. While in the central nervous system, we have oligodendrocytes, astrocytes, and glial cells that all work together to support the neurons in this area. But there are different types of Schwann cells. There are these myelinating Schwann cells that myelinate the neurons by wrapping its plasma around it. And then we also have these non-myelinating Schwann cells. And the function of the myelinization is to increase the signaling speed of the neurons. But let's take a look at the non-myelinating Schwann cells. They can be further divided into Remock cells and perisynaptic Schwann cells. Let's start with the Remock cells. Remock Schwann cells surround C fibers, for example, which are slow signaling nerves for pain and temperature. But what is the function of having a non-myelinating Schwann cell? Well, the function of the myelinating Schwann cell is to increase the signaling speed, but this comes with its own downsides. The plasma of the myelinating Schwann cells contain growth-inhibiting molecules that, when wrapped around the nerve, inhibits outgrowth and collateral sprouting, and also regeneration of the nerve fiber. This regeneration inhibiting effect is very important in the brain, for example, where you don't want your nerve fibers to connect in the wrong way. But remember that the nerve fibers in the CNS is myelinated by the oligodendrocytes. Now back to the Remock cells. These cells allow the outgrowth and collateral sprouting of the nerve fibers, and one function of this is, for example, to allow these C fibers to respond to pain signals, and by collateral sprouting innervate an area that has been deinnervated by a wound, for example. Another function of these non-myelinated Schwann cells are to provide metabolic support. And one example of this is by providing the axons with lactate that can then be converted into ATP and used for energy to fuel the ion channels of the neuron. Lastly, let's take a look at the perisynaptic Schwann cells, also known as terminal Schwann cells or teloglia. The functions of these are not well understood yet, but there are theories that they function kind of like glial cells of the brain, and that they regulate the formation and maintenance of synaptic connections at the neuromuscular junctions. And some studies have shown that these cells play an important role in the formation of synaptic connections during embryonic development. And that covers everything for this video. I hope you learned something, and thank you for watching.